Okay, this is Unit 910, looking for relationships, and we're working away here in Box K, trying to working on finding relationships. And what we want to be able to do by the end of this lesson is to find the equation representing a relationship if we are given a table of values. Okay? And this is going to draw on some of the skills that we learned in Box 8, where we were working with finite differences. So, just to start us off here, relationships that are linear can be represented by rules or by equations. The finite differences can help us find the equations if our x values increase by 1 in each row. Okay? So we're going to be working, again, this is a table like we saw back in box H here, where we've got x and we've got y, and we want to calculate our finite differences. What we want to make sure of here is that our x values are increasing by 1 in each row before we even start. So let's take a look. Yep, this is going up by 1, by 1, by 1, and by 1 each time. So we're good in terms of those x values. Next up, we want to calculate the finite differences. And remember, finite differences, we're looking at our y values here. We want to start at the bottom of the table with one y value, and we subtract the one above it. So negative 2 minus 1 is negative 3. And then we move up in the table, 1 minus 4, negative 3. Move up in the table, 4, subtract the one above it. One above it is 7, negative 3. 7 minus 10, negative 3, and we can't really do anything with that top one because we run out of y values. So first thing we notice is we notice that all of our finite differences are the same. This tells us that our relationship is linear, and it needs to be a linear relationship if we're going to get an equation to represent it at this point. Well, later on in your math career, you'll learn how to do equations for more complicated nonlinear functions, but today, for this course, you just have to worry about being able to do linear ones. So what we can see here is that each time our x goes up by 1, our y values are changing by negative 3 each time. Okay? And what we want to think of is we want to come up with, over here, we want to come up with some rule that is going to allow us to take some x value, okay, and turn it into a y value. Okay? We're going to do a series of operations to our x, and it's going to give us this number that we have in y. The first thing we're going to try doing to our x is multiplying it by this finite difference of negative 3. Okay? Negative 3 times x. So we're going to take each one of these x values, negative 2, negative 1, 0, 1, and 2, and we're going to see what we get when we multiply negative 3 by that x value. So let's see. Negative 3 times negative 2 is going to give us 6. Negative 1 times negative 3 is going to give us 3. 0 times negative 3 gives us 0. 1 times negative 3 gives us negative 3. And negative 3 times 2 gives us negative 6. Okay. Then what do we have to do to these numbers here that we've gotten by multiplying our x by that finite difference? What do we have to get to turn these numbers into these y values over here? Well, if I've got 6 and I want to turn it into 10, I have to add 4. Same thing for my 3. If I want to turn it into 7, I have to add 4. Same thing with my 0. And it's the same thing every time. If I want to turn each number in this column here under my negative 3x into my y value, I have to add 4 each time. So that tells us if we're starting from an x value and we want to get to the y value, what we should do is we should take our x value, multiply it by negative 3, and then add 4 to it. So y is equal to negative 3 times x plus 4. This is like a little rule for going from one x value to the corresponding y value. Okay? So that would be the equation right there. That's our final answer. All right, so let's do another one here. Okay. Another table here. First thing we should do is we should check to make sure everything is going up by 1 each time. Yeah, 1, 1. Okay, we're good, and we're good. Calculate our finite differences here. 12 minus 9 equals 3. Remember, looking at the y values, subtract the one above it. 6 minus 3 is 3. 3 minus 0 is 3. Okay, and we're done. Okay, so our finite differences are 3 every time. So we know we have a linear relationship. So we can go ahead and we can try to find our relationship here. So we're going to start by taking our finite difference 3 and multiplying it by each one of our x values. So let's see, what are our x values here? They are 2, 3, 4, 5, and 6. Okay, so 3 times 2 gives me 6. 3 times 3 gives me 9. 3 times 4 gives me 12. 3 times 5 gives me 15. 3 times 6 gives me 18. Now, what do I have to do to go from my values here in this column to these values over here? Well, to go from 6 to 0, I have to subtract 6. And this second step is always going to be an addition step or a subtraction step. Okay, we do multiplication, that first step, then it's either addition or subtraction. Okay, again, minus 6, minus 6, minus 6, and 18 minus 6 gets us 12. So what do we have to do in order to go from x to y? Well, we can say that to get an individual y value, we have to take our x, multiply it by 3, and then subtract 6. So that is our relationship right there. Y equals 3x minus 6. Last one right here. This one is trickier. Okay. Notice, this is probably the hardest one we're going to ask you to do here. Our first step is we check our our x values. Do they go up by the same amount each time? No, they don't. They're going up by 2 each time. Okay. So there's an extra step that we're going to have to do here every time. So let's go ahead and calculate our finite differences. Okay, we start at the bottom, subtract the one above, we get 2. 1 minus negative 1 is 2. Negative 1 minus negative 3 is 2. Negative 3 minus negative 5 is 2. We can't do anything there. So we've got 2, 2, 2, 2. Finite differences are all the same. So this is, in fact, a linear relationship. Okay. The test for linear relationship still works because these are going up by the same amount each time. Okay. What we have to think to ourselves, though, is remember the finite difference tells you how much y is going up by each row in your table. We want how much y goes up by when x changes by 1. So if in our table here x is changing by 2, we want to know, well, if x goes up by 1, how much would y go up by? Well, if y goes up by 2, okay, when x goes up by 2, then if x only goes up by 1, y is only going to go up by 1 as well. So over here in this other table, when we take our finite difference and we multiply by x, we're not going to use 2, we're going to use 1, okay? Because that's how much y is going up by each time we change x by 1. Okay, so we got 1 times x. Let's finish this thing off here. So we take our x values, 1, 3, 5, 7, 9. We multiply 1 times our x values, so we still get 1, 3, 5, 7, 9. And then we think, what do we have to do to go from that column to that column? It's either addition or subtraction. It's going to be subtract 6. Yep, and this works for every single one of these. Nope. Sorry, I put these two in the wrong order. 7, 9. Let's double check here. 7 minus 6 gives me 1. 9 minus 6 gives me 3. Okay, that's good. So in order to get our y value, we are going to take our x value. Okay, we could say multiply it by 1, but remember when the coefficient is 1, we don't write that 1 in there, and then we subtract 6. And that's going to be our relationship. Y equals x minus